Hello class, welcome back. We wish you have some ideas about the linear regression, the R-part regression tree, and an M5 regression tree, because we're going to introduce a new data set and we want to create and construct these three different types of models using this data set. And then we will compare their performances. So let's first import this white wine dataset into R, and then see the structure of our dataset. So as you can see, in total we have 12 different variables, and all of them are numeric variables. Well, it includes some features for the wine, so some sugar, acidity, density, pH value, and alcohol, and so on. So the target variable for this dataset is quality. So we want to use the rest 11 variables to predict the quality of this white wine. And well, let's see the summary of the quality. So as you can see, the value range for this quality is from 3 to 9, and the average quality is around 6. And well, next we want to check the correlation between different numeric variables. Because all 12 variables are numeric variables, we can directly use the dataset name inside this correlation function. It will generate a correlation table for all 12 variables. So, well, we want to find the features that have like higher correlation with our quality. So basically, density of this wine and the alcohol volume, alcohol quantity, has the highest positive and negative correlation with our density function, our quality variable. Well, you can also visualize the correlations using the pairs panels function. Well, because we have like 12 variables, so it will take a long time to load. So you can definitely try it offline. Well, next we want to build the linear regression models first. We will first partition this white wine dataset into training and testing dataset. Well, similarly, we'll use like 50% of the instance to compose a training dataset, and the rest 50 we will further partition them into testing 1 and testing 2. And for testing, for testing 1, it contains 25% of the instance. So for the testing, similarly for testing 2, it also contains the rest 25% of instances. And then we will build a linear regression model using the training dataset. So let's build the model and see the results. So let's see the summary of this model. So as you can see, there are a few variables, a few like features, predictors are not significant effect of quality in our model. So for the R-square and adjust R-square, like almost 31% of the variance from the training dataset has been explained by this model. So it's not very good because only 31%. And next, we will generate the prediction for the quality of wine for the both testing 1 and testing 2. So we still use the predict function. And then this time, we directly use the metric and specify the measures, the error measures correlation R-square. While we include every measures in this function, and let's check. So basically, when we testing on the testing 1, testing 2, the R-square reduced a little bit from 31% to 24 and 26%. Well, the correlation is almost 50, like 50%. Next, we will use a similar for loop steps to generate the three pairs of randomly generated training and testing datasets, and using the three pairs of training and testing dataset to get the average performance for this linear regression model with our dataset. So, well, we also used 66% of the dataset to compose our training dataset, and the rest is 34% to compose the testing dataset. And we use the raw means to get the average evaluation measures. So let's run this chunk and check. So still basically the R-square is around 27%, and the correlation is about 0.51. Next, we will use the originally training and two testing datasets to compose the R-part regression tree models. So let's first build this R-part regression tree model with quality as target variable and the rest of the features as predictors. And let's check this regression tree model. So in total, it gives us 11 different nodes. So let's find a path in this regression tree. So if the first split node is alcohol, so if alcohol level is less than 10.85, and we will go to another split. Well, if the volatile acidity is larger than 0.2375, well, we will go to the further split, which is also the alcohol. So, and if alcohol level is larger than 9.85, well, the quality value for this one will equal to 5.6, almost 5.6. And let's visualize this plot. Well, you can also use a summary function. It will give you detailed information for each node about the split, about how many instances on the left-hand side node or right-hand side node. So let's check this plot. Well, so similarly, well, alcohol is our first split, and then this is the acidity, I think, and then alcohol is another split. So let's see. We then use this model to generate the prediction of quality value for the instances in both testing dataset, still using predict function. And then let's evaluate the performance of the prediction using that metric. So, well, you can see when we use the linear regression model, the R-square is almost 26%. But now for the test dataset 1, the R-square dropped to almost around 20%. And for test dataset 2 is 26%. So next, we will also use the three pairs of randomly generated training and testing data generated by for loop to obtain the average evaluation for this R-part regression tree models. So the steps are all similar. So we will also use the raw means to check the average performance. So let's run this chunk and see the average performance. Well, similar to linear regression model, well, we have a R-square almost 26%, and the correlation value is around 0.51. So next we will build M5 regression tree models, still firstly using the original training dataset and then testing using the two testing datasets. So let's run this chunk. So it generates how many rules? 20 rules, which means, let's see, basically generate 12 different leaves, and therefore we will have 12 different linear models on that leaf that has been generated. And let's see the performance. So for the testing data 1, well, the R-square value reaches 30%. For the R-square for the testing data 2, we reach 35%, which is a big improvement and compared to the previous two models. And the correlation has also increased. I think the errors, they decreased when we use this M5 model. Well, let's also see the three training and testing pairs to check the results, to check the average performance. Yeah, basically we will have R-square equals to around 31% and correlation around 0.56. So this correlation is pretty high for this M5 model. And well, in the end, we will compare the average model performance for these three models: linear regression, R-part regression, and R-part regression tree, and M5 regression tree models. So let's see. So here, let's see our final comparison results. So first of all, let's see the error measures. I think M5 generated the least errors, while R-part regression tree generate the most errors. And in terms of the correlation and the R-square, I think M5 performed the best comparing to these two models. And these, in terms of correlation and R-square, linear regression, R-part, I think they perform similar. So basically, this is how we use this new dataset white wine to construct three types of models: linear regression, R-part regression tree, and M5 regression tree, and compare their performance evaluations. So that's all for this tutorial, and thank you for your time and thank you for listening. Bye.